Hello, Prof. Rassi here, looking at class activity 9A again with the popsicle sticks problem. We're going to write an expression for how many popsicle sticks. So you could just count 1, 2, 3, 4, 5, 6, but it's going to take a long time, and you really don't take advantage of the structure that's in this scenario. So go ahead and pause it and come up with a way to calculate the number of popsicle sticks using the structure you see. Now, I'm going to do the same thing. There's lots of ways to look at this. This is not the right way to do the problem. It's just one way to do the problem. So when I was looking at it, the structure, I saw a couple things. I saw these triangles here on the top and the bottom. So I see all of these triangles. I'm going to switch colors here. Similar shaped triangles on the bottom. Then I saw the popsicle sticks down the middle. And then last, I saw the popsicle sticks here on the ends. So if I'm going to write an expression for that, I'm going to start out with the ones across the top. 5 times 3 plus the popsicle sticks across the bottom. There's 5 of those times 3 sticks in each one, plus the ones down the middle. There's 6 down the middle, plus the ones on the ends. So I've got here 2 sets on the end that each have 2 in them. And so that's the structure I saw. You could have looked at it many different ways. If I calculate this out, I end up getting 15 plus 15 plus 6 plus 4. So that's 30 here plus 10 here for a total of 40 popsicle sticks. So if I've done that correctly, you should also get 40 popsicle sticks for your expression as well. I was going to say something. Oh, some of you are probably noticing here that there's a repetition here, there's a structure here. So if we wanted to, we could be sneaky and put this as 2 groups of 5 times 3, and that would take care of the top and the bottom at the same time. The number of ways to do this, there's a ton of them, and I encourage you to post your method in the discussion board. Now the next question says that this expression was 6 wide. How many would there be if it was 8 wide? In other words, what if instead of 6 down the middle, there were 8 down the middle? And it might depend. You might see it differently. I kind of picture adding these triangles on the ends, so there'd be 2 more sets of triangles here. But depending on how you designed it or drew it, ooh, okay, I see what I'm doing. Thought I made a mistake on my previous slide. The way I was thinking about it, though, was these 3 triangles sticks on the bottom and top, these 3 here, and I'm running out of room, but you can picture that there. And so it's kind of squished here, but you see I've added and extended it. So how many are in 8 wide? If we were just counting, we would have to start completely over. But since we were looking at structure and thinking about structure, we actually have a bit of a shortcut we can use here. We knew before there were 5 sets of triangles, top and bottom. So now, with it being 8 instead of 6, there should just be 2 more sets of triangles. So that's 7 times 3. Same way here, instead of 5 triangles on the bottom, there's 2 more, so there's 7. Instead of 6 popsicle sticks down the middle, there's now 8. And we still have the 2 sets of 2 on the end, even though in my picture it's not going to be very pretty. We've got one here, and we've got this set here. And so that it gives us an expression for 8 wide. I don't know what it is off the top of my head. 21, 21, 8, and 4. So that's 42, 54 popsicle sticks wide. So again, just looking at structure and writing expressions and seeing how the structure in the expression